Alright, so we finished about the electron, right? And heavy charge particle, that means other charge particle except electron. Okay, so could be a proton, that is hydrogen without an electron, and also deuteron, tritium, alpha particle, and other heavy charge particle and pions. So we call this is heavy charge particle. So for this table, for this page, we can separate it in charge and non-charge. Okay? And for non-charge, we can separate it into photon or neutron. Okay? And for a photon, it interacts with the orbit electron. For a neutron, it interacts with the nucleus. Okay? And for heavy charge particle and the electron, it's using the Coulomb force to interact with the material. Okay, so we just separate it into these categories. And all of this radiation can ionizing material, so we call it ionizing radiation. Okay, all of this is ionizing radiation. All right, so we move to next. For X-ray or gamma ray, gamma rays emit from the nuclide, excited nuclide. It will release its energy. So we using the h nu to express the energy of it. And you can know that h is Planck constant and the nu is the frequency of that wavelength. So when we all know the frequency could write down like could be the light speed divided by the wavelength. So we can using this term to expression the energy of a gamma ray. So in this equation, we can see that for energy, for wavelength, and for the frequency, all can describe the photon or the wavelength or the EM wave. So we have you must have a concept when we talk about photon energy. You can come out its frequency or its wavelength. All right. So it can change each other too. Okay. So when will we using wavelength to describe an EM wave? When will we using energy to describe a photon? Depend on its phenomena. So it is it's a term to phenomena of the EM wave, right? So 就是它的这叫什么 EM wave 啊，电磁波。当它的特性比较像波的时候，我们就用波来表示它，用波长来表示它。当它的特性比较像是光子的时候，我们就会用粒子的特性，就是用能量来表示它，这样子。那它有波粒二重性，这样子。Okay, so I hope you can get it. So for our radiological physics, we're using photon to express its energy. Okay, and for other EM wave like UV or the energy lower than UV, like a visible light or a microwave, we're using wavelengths to describe it. Okay, but for you, you must have the ability to transfer this three quickly. Okay. All right. So here is an derived equation from the energy, from energy to the wavelength and to the frequency. So once you get energy, you can using this term to if you have the wavelength, you can using this equation quickly to change its to quickly to get its energy. So for this equation, you must give the wavelength in angstrom. Do you know what is angstrom? 你们知道什么是 angstrom 吧 ？Yes, yes. Okay. 1 angstrom equal to. Okay, so you got this. Okay, so if you have a wavelength, you transfer it to angstrom. You can using these constants to convert its time. You using this constant to divide its wavelength in angstrom. Then you can get its energy is keV. Okay, it's derived from the original one. So here light. So you must know what is the light speed. Is around this one, right? 3×10 的几次方 Okay. Okay, so we must quickly to do that. And how about this one? 1 eV equal to Joule. Right? Okay, so you must have the ability quickly to transfer of it, and then you can get these constants by yourself. Okay, and I will not go detail of it. I just to go through another. So for X-ray, you can see that we're using different terms to express X-ray. Here it's very important. You can see the energy. Gamma, we're using this term, right? And for X-ray, we're using this term. What's the difference? This is voltage. Voltage. kV, kilovolt. MV, megavolt. But why are we using this grid to express photon energy? It's very interesting. But this is energy, right? 1 MeV is around joule. It's the same energy level. It is energy. But this is not energy. But why are we using this to describe X-ray? Okay, I give you an idea of it. When we talk about 100 kV, sorry, K should be like this one. Okay, 100 kV X-ray. It's not just say one kind of energy. It's a spectrum. Is an X-ray spectrum. So when we talk about X-ray, it means we're using 120 kilovolt to accelerate the electron. So 120 kV to accelerate an electron. What will you get for that kind of electron energy? 电子在120 kV 下面被加速的时候，它会得到多少能量？ What is the kinetic energy of that electron? It will be, right? Okay? Alright, so when we talk about 120 kV X-ray, that means it produces this energy of electron. And this electron hit something. Most of it may be the tungsten. to produce X-ray. So it produced electron, heat tungsten, and produce X-ray. And this X-ray will be, the spectrum will be like this one. Here it's 120 kV. Here, I'm not sure, depend on its filtration. So all of this produced by the electron, heat the tungsten, cause the branch column. This is branch column. Okay, and these two peak, this one is higher, this is lower. Okay, it provides these two is characteristic X-ray of tungsten. Okay, so when we talk about 120 kV, we talk about the spectrum like this one. It's not just one energy, it's a spectrum. 可以吗？所以当我们讲 X 光的时候，不可能是单一能量，除非它讲的是特性辐射，不然的话它就一定是一个能谱。那它讲的就是指你把电子放在120 kV 的电压下加速的时候，电子得到120 kV 的动能，而这一群电子呢，去达到乌靶的时候，有些呢就产生了自动辐射，大部分都产生自动辐射，然后它产生的 X-ray 就长成这样子。那少部分去击中到钨的那个 K 层或者是 L 层的时候，它就留下空洞，所以它后续就会产生特性辐射。所以呢，我们就会观察到有两根屁股在这里，是钨的特性辐射。那一般来讲，我们都用钨来当做被打的东西，所以呢，我们很正常的就会想到 ，OK， 那个120 kV 的 X 光就是长成这样子 ，OK。Alright, so it's a little different of it. Alright, so here is the X-ray and the gamma ray. Then we move to this part. What is this one? Okay, energy range. So what kind of energy range could be the ionizing radiation? For gamma ray, could be MeV to 10 MeV from the nuclide. For X-ray, you can accelerate any kind of electron to get a lot of energy from keV to MeV. Okay, and for electron, I'm sorry, I'm spelling wrong. Electron. Here is R. Electron could be 1 MeV to 50 MeV, and the proton could be 200 MeV, and the alpha particle could be 1000 MeV, and the neutron can up to 70 MeV. So that is the general range. Okay, and here is the interaction. So I hope you have the clear mind of it. This ionizing radiation here, ionizing radiation could interact with any kind of material. If we focus on human or our biological things, that is a soft tissue, okay? And these two terms, we're using air because air is similar to our soft tissue. So if we have an air radiation interact with our air, we can say that this phenomenon is similar to the radiation interact with a soft tissue. So sometimes the matter we focus on air. And how about water? Because the air has low density, so the X-ray interact with it, the probability is not that high. So once we would like to find an intense interaction, so we need something that is similar to our body. So for solid things, we're using water. Or other things like hydrogen. The plastic made by hydrogen, carbon, and oxygen. So that is a kind of plastic. we can using in our material. So for this tool is for our measurement, radiation measurement. We're using these things to pretend the soft tissue. Okay, if you would like to do some radiation measurements, and other material focus on what kind of things you would like to discover. So maybe for the TSMC, not an industry over there, they would like to know IC chips, right? Okay, so if you focus on IC chips, it might be the interact with the silicon or something, or maybe some metals. Okay, so any kind of things could be interact with the ionizing radiation, but I hope you can know of it. For charged particle, it interacts with material from the Coulomb collision 就是由这个库伦力的作用，而这个库伦力的作用，他们会把它用成 collision， 但它并不是真的碰撞。It's not physically collide. It's an interaction of the charged particle. Okay, and for photon and the neutron, it has some verb you need to learn. One is scatter, the other is absorption. So scatter means this photon interact with the electron, and the scatter change its direction. We call it scatter. 散射. So another scatter is neutron interacts with the nuclide, and it changes its direction. This also scatter. So we could have photon scatter or neutron scatter. All right? Is that clear? Okay. So what is absorption? Absorption means the original one disappear. Okay. So the photon interact with the electron, and the photon disappear. Okay. That means photon was absorbed by this process. Okay, and how about the neutron? Neutron can be absorbed by the nuclide. And in English, we call this kind of neutron absorption, we call it neutron was captured by the nuclide. So capture 就是中文就是捕获 Chinese is this word. Okay, so you can write down like neutron scattered by the nuclide. You can draw like this one. Neutron interact with a nuclide, and then neutron was scattered in another direction. So this is scatter. And how about neutron interact with a nuclide by absorption? That means you have a mass like A, and it becomes A plus 1 because neutron was absorbed by this nuclide, and this nuclide would be in an excited state, and then it will emit something. So this emit something could be N gamma, N P, or N or N P, or N alpha. Okay, so for capture, neutron will absorb by the radionucleus, and maybe its following process maybe emit gamma, emit proton, or emit neutron, or emit neutron and proton, or emit alpha. Depend on what kind of nuclide of it. 就是它最后得到捕获的时候，就是中子被吸进去了，然后那个原子核的质量就加1，那它就是在一个 excited state， 然后它就一定是想要把自己的能量放掉，所以放掉能量的方法，它就是丢出东西来，那可能是丢出粒子，也可能丢出光子，所以如果丢出光子就叫 N 伽马反应，那如果丢出粒子就看它丢什么粒子，啊，比如说像硼的话，硼10的话，它就会丢出阿尔法，所以我们叫它 N 阿尔法反应。这样可以吗？所以当你看到这个 term 的时候 ，when you saw the term like this one, you should know that it is an neutron absorption process. Okay, all right. And how about the gamma was absorbed by electron or nuclide? It's from two parts. If we say photoelectric effect, that means the photon was absorbed by orbit electron, and the photon disappeared. Electron was injected. Okay, so you can draw like this one. So the gamma incident here, and no, I'm sorry, the photon incident here, and the electron was injected. So this is photoelectric effect. So the original photon disappeared. Okay, what is the pair production? It is like this one. It has two processes. One is the photon interacts with the nuclei, and it exchange is energy. Exchange is energy into electron and the positron. Okay, we call it pair production. But this process also could have a higher photon with higher energy interact with the orbit electron. What is this kind of process? It's triple production. Do you know that? So if this one thing is photon also inject the orbit electron and also inject a pair, so we call it triple production. It is a part of pair production. So when we say pair production, it incorporates these two things. All right. Okay, so photon will disappear through the absorption process, but the photon will change its direction during the scattering process. Okay, so that is all interaction. I hope you are very familiar with this phenomena, and because the radiation dose, when we talk about radiation dose, we deal with these things. Okay, and how can we describe the ionizing radiation? Okay, first of all, we would like to talk about random nature of a radiation. You cannot determine it interact or not. It depends on the probability. It depends on the stochastic process. Okay, so if we would like to talk about this one, we will focus on here. We would like to talk about the stochastic quantity and the non-stochastic quantity. Could you give me your opinion about these two terms? Discuss with your classmates and talk about what is stochastic quantity and non-stochastic quantity. What is the key point to determine these things? 就是讨论一下什么叫做几率量，什么叫随机量，什么叫非随机量，好不好？Is independent of the energy or take care of your like the physical example for instance when ionizing radiation interacts or no one is that with you. So let me. Do you know what is stochastic and We will learn later. It has a quantity. About the graph because for not stochastic there is yeah it's probably okay. So for stochastic quantity, that the answer from that group, they say that you cannot expect what is the value of it, or you cannot expect it interact or not. It depends on the probability. Okay, so what is the stochastic? Radiation interaction with the medium or material is a kind of stochastic quantity or not? Please express your opinion. Okay, I would like to go back to the definition. Stochastic quantity, that means you cannot expect what is the exact value of it, or you cannot expect the interaction, have the interaction or not. Okay, then this is the definition of the stochastic quantity. But I would like to move another question. The question is, radiation interacting with material is a stochastic quantity or non-stochastic? Okay, please raise your hand. You think that is stochastic quantity? Please raise your hand. Okay, you think that is non-stochastic? Okay, only one. How about you?
I think it's both because there is this, for example, when as you increase the surface area of the target, then the amount of ionizing radiation is like has a linear dose relationship with the effect on the material.
Yeah.
But for stochastic quantity, like even the amount of energy like in this is still follows the Gaussian. So like I'm expecting this amount of radiation to come up and interact with this particular material, but it still has a 95% probability that
Yes.
some energy will not interact with this material.
Yes. Okay. The correct answer is both. Both. Depend on the situation. If you just focus on 10 photons, and you would like to know if these 10 photons hit one target. I don't know what is this one. Okay, the 10 photon will hit this one. It depends on the interaction probability. You cannot expect its amount, right? So for this situation, the photon number is very few. It's a kind of a stochastic quantity. Okay? And another situation is if when I have a lot of photons, maybe 10 of power 9, and I would like to know it hit the DNA or not. DNA is very small, right? It's around angstrom or nanometer. So for small material or small dimension of the material, this interaction is also stochastic. Okay, so two situations: fewer photon, fewer radiation, or small target. The interaction is stochastic quantity. But when you both this large enough, it would be a non-stochastic quantity. Okay? Okay. So I hope you get these ideas. So for NE is an expectation value. Expectation value is you using an radiation penetrate a finite sphere. Then you can expect how many radiation, or how many the radiation will interact with your sphere, and this means it's mean the mean value, the expectation value of your NE. So that is a kind of experiments results of this problem. So I'm using this term to redrawing the original figure from the textbook. So we call this one is a sphere. So we're using S to express it. It's a volume. It with a volume V, and if we see each element or the differential volume, we call it dV. And this sphere also have its mass, or you can call it. It should provide the density of this material. Okay, so it has a mass, and if we see the small amount of the mass, we're using dN. All right, and when we talk about the radiation across the material, we will create an area. Okay, so we're using is an area, or A or dA, to talk about the radiation across the area. Okay, and be careful, because we talk about the radiation interaction, we will identify a location. So the P point is the central point of this sphere. We call it P point. That is our position. Okay, so if this material, or you would like to say the photon, the radiation interact with something, it must have volume. Must have the volume here. Okay, if there is no volume here, no interaction. Okay, but you can define the volume is large or small. Okay, but we will localize the point. That means the position of this volume location. Okay, so first part we have 10 minutes of it. So describe of your classmate. Oh, we already do that. So I hope you can go through the content of this one and write down by your own definition. I will place it in our homework. It's easy because I have described it, and I also provide the definition from the textbook. But I hope you can use in your own words to describe it in Chinese or in English. It's okay. Okay, but I hope you using your familiar language to describe it. 就是我希望你们呢，就是写这个作业。那写作业其实我也把答案都告诉你们了，对不对？可是我希望用你理解的方式来写这个作业。主要的原因是因为你们会发现你们会有很多的想法，或者是知道很多东西，可是这种狗就会通通都搅在一起。那人家在问的时候，你好像有点搞不清楚定义，所以我们这一堂课有很多时候都会要让你写作业，但是就是用自己的了解的方式来写。当然你也可以抄，但是请记得，我的目的不是在于你交不交作业，我的目的在于你理解它之后有话说。所以重点是你理解它，然后写作业只是一个程序而已。OK， All right. So So what is the field definition? We using this term to describe the material. That means the object, the radiation interact with it, right? But we need to define what is the amount of radiation. So we have different ways to describe it. I have told you, right? So we have an fluence and energy fluence. So for fluence, that means you define the area that radiation incident is and how many particles per unit area. That is fluence. Okay, so that is fluence. And if this radiation with some energy, we consider the area. What is the energy passed through this area? We call it energy fluence. Okay, and sometimes we call it flux. So when you see the English words like fluence, you should come out this definition to you. And when we talk about the flux, you should think about this one. And in this textbook, it using R to expression the radiation energy. Okay, and this radiation energy, if in the original SI unit, we were using joule to express it, right? But because we talk about the particle interact with material, and we also say this particle from the isotope or created by X-ray spectrum. So sometimes we using EV to express energy. Okay, and most of it we using EV. But you must have the ability to change each two, because EV is from our description, and the joule is for SI unit. Okay, all right. And do you know this one? It's old unit. It's
equivalent radiation.
Yeah, that means I forgot its definition. Okay, never mind. It seems, is that right? I'm not sure. But this erg is not come out anymore. But this textbook talk about it because the author is around, its activity period is around, I guess so. So this is its a period. So in this duration, they using ERG. But right now we're using SI unit. So you don't need to memorize it. It's okay. So you don't need to memorize this one. Okay. All right. And what if we consider the time, the fluence changed depend on time? We will using the rate, fluence rate. Okay. I'm sorry. So flux is for fluence rate. I'm sorry. Make the mistake. Okay. So here is the per second, and the energy fluence depend on the time. Then we call it energy fluence, energy fluence rate, or energy flux density. So you can see these terms is all talking about how many photons pass through an area, depend on time or not. Okay, so that is the field definition to talk about the amount of radiation. Okay? Yeah. Okay, before we go through it, it takes time, so we take a 10-minute rest, and then please go back at 11:05. Okay, 11:05.